You ever see one of those massive tunnels, carved right through a mountain, and just think, how in the world did they even do that? Well, the secret isn't just about the giant machines. Nope, it's actually hidden away inside a document, a super detailed blueprint that spells out every single step. So today, let's unpack the plan for this incredible engineering marvel. So, who's behind this whole thing? The organization taking on this massive undertaking is Indian Railways, a name that's pretty much synonymous with connecting an entire subcontinent. And for this project, they're not just laying down some track. They are seriously pushing the limits of what's even possible in railway engineering to create a brand new, vital corridor. And the scale, it is just staggering. We're talking about 9.06 kilometers of tunnels in total. That is over 5.5 miles of solid rock and earth that has to be systematically carved out, secured, and totally transformed, all for the next generation of high-speed trains. Which brings us to the big question, right? How do you coordinate thousands of people, tons of material, and all this complex machinery to build something so colossal? Seriously, where do you even start? Well, the answer is, surprisingly, pretty simple. It all starts with a document. This one here is called the technical specifications. And trust me, this isn't just a guideline. It's the rule book, it's the recipe book, it's the master plan, all rolled into one. Every single thing that happens on that construction site is dictated by what's written in these pages. And this is a great reminder that these documents aren't just anonymous paperwork. Behind every clause and every number, there are actual people. These signatures, they represent the engineers who checked, double-checked, and approved every last detail, putting their professional reputations right on the line. It connects this abstract plan to real human accountability. Okay, so first up is something you probably wouldn't even think about. Before you can dig a single foot of the tunnel, you have to build a place for the builders. You basically have to construct an entire temporary city right from scratch. In the engineering world, this is called temporary works. It's all that critical infrastructure, from housing and clinics to power plants, that supports the main construction. And the really important part here is that it's all designed to be completely taken down once the project is done, leaving behind as small a footprint as possible. And listen, we're not talking about a few temporary huts here. The plan calls for a fully functional community. It's got everything from employee camps and medical clinics to its very own independent power supply and water systems. There are even dedicated repair shops for all the heavy machinery and a field lab for on-site testing. It's a logistical masterpiece before the main event even kicks off. And if you want a perfect example of just how ridiculously detailed this gets, check this out. The document specifies everything, right down to the sanitation, saying there has to be one toilet for not more than 5 users. It just goes to show you that the planners have thought of everything, from the biggest engineering challenges to the basic, everyday needs of the entire workforce. Okay, so the city is built. What's next? Well, you need your ingredients. This next section of the document is basically the recipe book for the tunnel itself. And believe me, the standards are incredibly precise. Just take a look at this table. This is the exact recipe for the aggregate that goes into the sprayed concrete, which is also known as shotcrete. It specifies the precise mix of different size particles you need. If that mix is just a little too fine or a little too coarse, the structural integrity of the entire tunnel could be compromised. It's an exact science, kind of like baking a cake, but, on a geological scale. All right, now for the main event, digging the tunnel. This is where the heavy machinery finally meets the mountain, and the whole process is this carefully choreographed cycle of digging and supporting, digging and supporting. See, modern tunneling isn't just about blasting your way through rock. It's actually a really delicate, repetitive cycle. You dig out a short distance, then you immediately spray a layer of support to keep the rock stable. Then you install deeper anchors. After you verify that everything is perfectly aligned, you just do it all over again, meter by painstaking meter. So the two key players in holding all that earth back are shotcrete and rock bolts. That shotcrete we just saw the recipe for, that provides an immediate skin to stop the surface from crumbling. Then the rock bolts act like these giant screws, drilling deep into the surrounding rock to bind it all together into one solid, self-supporting arch. It's a pretty ingenious way of making the mountain itself part of the structure. So with the tunnel structure totally complete and secure, the focus shifts to what goes inside it. It is finally time to lay the path for the trains.
Now, instead of those old-school tracks with all the loose gravel, this project specifies a modern ballastless track. Here, the rails are fixed directly onto a solid concrete slab. This gives you way more stability for higher speeds, and, this is critical, it requires a lot less maintenance. Inside a tunnel where access is tough, that low-maintenance design is a total game changer.
So, at the end of this whole incredible process, what you have is a perfectly engineered passage. It's a smooth, unbelievably stable and durable path that's built to last and ready to handle the next generation of modern trains.
And of course, we can't forget the minds behind the plan. This whole complex blueprint was developed by the expert engineers at RITES Ltd, an infrastructure consultancy firm, and they did it all on behalf of the Northwestern Railway. This thing represents the culmination of decades of expertise and precision planning.
We've just unpacked the hidden instructions for one single mega project, but it really makes you wonder, doesn't it? What other invisible blueprints, from building codes to the software protocols on your phone, are silently shaping the complex world all around us, every single day?